Good day and welcome to One-on-One Maths Private Tutors. Today we start on a topic, categorical, numerical, and grouped data. This is part of O Level IGCSE Mathematics, where we'll be looking at the section of statistics. Now, statistics is a branch of mathematics that deals with the collecting, analyzing, interpreting, and presenting data in an organized format. So the main aim of statistics is to summarize data. It is a branch of applied mathematics. So we'll start with collecting and grouping data. You may have heard headlines like One Direction, which is a band, is the most popular band, or teenagers voted Diet Coke as the best soft drink. Now, in order to come to that conclusion, such information is collected from a population or a sizable number of people so that they come to that conclusion. And they can present it in this way. So when we are looking at a particular class, we call that categorical data. It is data grouped in some sort of class. For example, if we are to collect information about people's car preferences, we would have to group that information by type of car. As an example, we can use this to say the most popular car brand is Jaguar. As you can see, 25% of the people liked Jaguar, followed by Nissan, because 20% of the people surveyed or asked preferred those cars. So this can be data collected and then it is summarized in the form of a pie chart like that. So that is the main role of statistics, classifying data into a category and then summarizing it. One way of collecting information is to ask people questions. This is done by carrying out a survey using a questionnaire, which is a list of questions, and then collect the answers on a data collection sheet. The answers are then analyzed or broken down to come up with a summary like this. Let's look at an example. Jamila is asked to find out how many people there are in cars that pass the school gate each day between 8:30 and 9 a.m. She writes down the number of people in the first 40 cars that pass on the first Monday. So this is the data that has been collected. Make a frequency table to show her results. So we can use a table to say number of people, and then we may have what we call a tally, and then frequency, which shows the number of occurrences. So for number of people, we may have 1, 2, 3, and 4. The maximum number of people in a car is 4. So how many ones are there? We have 1, 2, 3, 4, 5. So in a tally, we say 1, 2, 3, 4, then we cross like that. That is 5. The fifth one we cross, so we can count a further 5. 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. So this is 5, this is 10. So we count again 5. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, then 5 across. Then we have 1, 2, and 3 there. Okay, so we have counted all the ones. So we have 1, 2, 3. So the frequency is the sum total as a number 5, 10, 15, 18. So we have 18 there. For 2, we have 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, then 5. And 1, 2, 3, 4, 5. Okay, and that 5. And we have 1, 2, 2. So we have 12 twos. We go on to the threes. 1, 2, 3, 4, 5. 1, 2, 3, 4. Then the fifth one we cross. Then we have 1. This is 5 plus 1, which is 6. Now we go to the 4s. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that is the frequency table. Now let's move on to surveys. When you are trying to find out some statistical information, it is often impossible to find this out from everyone concerned. Instead, you ask a smaller section of the population. This is called a sample. When you are choosing a sample, your sample size is very important. If your sample is too small, then the results may not be very reliable. In general, you need a sample size of 30. If your sample is too large, the data may take long to collect and analyze. So you need to decide what represents a reasonable sample size for the hypothesis or the idea you are investigating. You also need to eliminate bias. So you must not target people who have or a sample that is like-minded. A biased sample is unreliable because it means that some results are more likely than others. Say if you're investigating the dangers of drinking, you cannot go and investigate at a pub. So it is often a good idea to use a random sample where every person or piece of data has an equal chance of being selected. But at times, you may want your sample to have certain characteristics. For example, when investigating the hypothesis that boys are taller than girls, if a random sample within the whole school would mean that all the boys selected happen to be in year 7 and all the girls are in year 11. This is a biased sample, as older children tend to be taller. So you may want to make sure that all the grades are represented and an equal number of boys and girls are selected from each grade. So even if your sample is random, it has to be controlled to make sure that it remains reliable. Let's look at an example. Candace is doing a survey about school meals. She asks every 10th person going into lunch, why may this not be a good method of sampling? So if you're asking people who are going into lunch, what about people who are not going? So there might be people who have stopped for lunch because they don't like it. So this may not be a good method because you are sampling only those who are going to eat the meals. And probably those who are going to eat the meals like them. The best way would be to also include those who are not going in to eat the meals, probably because they have stopped eating the meals because they don't like them. Data collection sheets. When you collect large amounts of data, you may need to group it in order to analyze it or present it clearly. It is usually best to use equal class widths for this. Tally charts are a good way of obtaining a frequency table, or you can use a spreadsheet or other statistics program or applications to help you. Before collecting data, make sure you design a suitable data collection sheet or spreadsheet. Think first how you will show the results, as this influences the way you collect data. So designing data collection sheets is important. You could quite easily collect data from every student in your class on the number of children in their family. One way to collect this data would be to ask each person individually and make a list like the following one. So for class 10G, you can just ask and write down the number of children in each one's family, and then complete the frequency table. Summarize the data in a frequency table. So all this data can be summarized like this. Before designing a data collection sheet, it is useful to know what the answer might be, although this is not always possible. For example, what would happen if you were using the tally chart above and someone said there are 13 members in their family? One way to deal with this problem is to have an extra line at the end of the table to record all other responses. Knowing that most families are between 1 and 5, it is very unlikely to have more than 5 children in a family, so you can just categorize more than 5 as one group. So this is a more summarized form than this. Now we move on to designing a questionnaire. A questionnaire is often a good way of collecting data. You list the questions you want to ask on a piece of paper and the respondent will answer the questions. Then you can collect the data you need. So when designing a questionnaire, you need to think carefully about what information you need and how you analyze the answer to each question. This will help you get the data in the form you need. Here are some points to bear in mind when designing questionnaires. Make the questionnaire short because people don't want to read very long. Only ask one thing at a time. Make sure your questions are not leading questions. Leading questions show bias. They lead the person answering them towards a particular answer. For example, this is a leading question example. Because of global warming, do you think that families should be banned from having more than one car? So you are leading a person by saying because of global warming. The right question would be, do you think that families should be banned from having more than one car? And the person should consider global warming if they want. If you give a choice of answers, make sure they are neither too few nor too many. Let's look at this example. Suggest a sensible way of asking an adult their age. So instead of writing 18 to 120, you can just group by an age range. So here we can say 18 to 25, 26 to 30, 31 to 40, 41 to 50, 51 to 60, and over 60. Then a respondent can just tick where their age group is. When you have written your questionnaire, test it out on a few people. This is called doing a pilot survey. So by analyzing your pilot survey, you can check whether your survey is possible. You may have to redesign or reword one or two questions, regroup your data, or change your method of sampling before you do the proper survey. So a pilot survey will enable you to catch out any practical problems that may be encountered in collecting the data. Two-way tables. Sometimes data collected involves two factors. For example, data can be collected about the color of a car and where it was made. Question. Peter has collected data about cars in a park. He has recorded the color of each car and where it was made. The two-way table below shows some of his data. Complete the table. There's a total row here, which will add all these columns, and a total column there, which will add all the rows. So we have to work out the blank spaces. So for this total, we add 15 plus 4 plus 2, which is 21. For this column, the total is 73. The red is 4. Therefore, not red is 73 minus 4, which is 69. For this column, the total is 15 plus 83, which is 98. For this row, 54 minus these two will give us the value here. 154 minus these two here, 69, plus 83, which is 2. And then the total here will be 4. For the total there, it's either we add these 2 or these 3, which should be the same as adding 154 and 21. And we get 174. So our table is correct because we can check with the column total and this row total. Now we move to averages and range, the mode and the median. The mode and the median are two different types of averages. The mode is the most common number in a set of numbers. A set of data may have more than one mode, or it may have no mode at all. The median is the middle number of a set of numbers arranged in order. In a list of n numbers, the middle number is 1/2 n plus 1. So to get the median, we must arrange in order, for the mode is the most common. Now let's look at this example. Here is a list of the weights of people in an exercise class. The instructor wants to know the average weight for the group. One way is to find the modal weight of the people. So which value is most occurring? So we have 73 there, 73, 73. Then we have 58, no more 58. Then we have 61, no more 61. Then we have 43, no more 43 kgs. Then we have 81, no more 81 kgs. Then we have 53, no more 53 kgs. Then we have 70 kgs and no other 70. Then we have 62 and no other 162 and no other 62. Then we have 60 and 85, no other. So the most common one is 73 kgs. So we can say the mode is 73 kgs. Or we can list these masses in order of size. So 43 is the least, followed by 53 kgs, followed by 58, and then 60, and 61, 62, then 70 kgs, then our 73s, then 81 kgs, then 85 kgs. So our median is 1/2 n plus 1, n representing the number of masses. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be 1/2, 12 plus 1, which is 18/2, which is 6.5. Now 6.5, our ranking is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6.5 is between 6 and 7, which means these two weights are being considered. So in order to get our median, we find the average of these two. So we'll say 62 plus 70/2, which is 66 kgs. So our median is 66 kgs. So these are our two ways of measuring the average weight of the group. Now we go to mean and range. The mean is another type of average. Mean is calculated as sum of data values over the number of data values. The range is a measure of how spread out the data is, and the range is largest data value minus smallest data value. So using our data for the weights of people, we may calculate the mean and the range. So for our mean, add up all the data, 43 plus 53 plus 58 plus 60 plus 61 plus 62 plus 70 plus 73 plus 73 plus 73 plus 73 plus 81 plus 85 all over 12, which should give us 66 kgs. It is our mean. For our range, we would have to consider the greatest data value and the least data value. So we can say range is 85 minus 43, which is 42. So the data is spread over 42 kgs. And the mean is 66 kgs. The mode is 73 and the median we have calculated to be 66 kgs. Let's look at an example here. Madia and Praveen play cricket. These are the number of runs they score in 5 innings. Calculate the mean number of runs per inning for each player. For Madia, we can say the mean is 7 plus 8 plus 5 plus 4 plus 7 over 1, 2, 3, 4, 5 over 5, which is 6.2 runs per inning. For Praveen, we have 10 plus 10 plus 2 plus 1 plus 6 over 1, 2, 3, 4, 5. This will give us 5.8 runs. Who is the more consistent batsman? So for consistency, the values have to be close together. So we'll find the range for Madia, the highest minus the smallest value, which is 4, which is 4. Now the range for Praveen is the highest, which is 10, minus the smallest, which is 1, which is 9. So since Praveen has a large range compared to Madia, Madia is more consistent because his values or his runs have a short range. So we can say Madia is more consistent. Thank you.